Good morning, grade 9. How are you all? Today we're going to discuss chapter 1, lesson 2, and we're going to talk about chemical properties and chemical changes. So as you can see from the definition of a chemical property, it relates a substance's ability to undergo changes that transform it into different substances. So whenever we have a change where there's a rearrangement of atoms and a new substance appears, we call that chemical change. And that's why a change can be in which one or more substances are converted into different substances. And that's called, as we said, chemical change or chemical reaction. So these are two definitions for the same process. So whenever a new substance appears, we call that chemical reaction or chemical change. Okay, so now we're going to talk about evidence of a chemical change. As you can see, in A, we have acetic acid in vinegar. So we have an acid and a base reacting together in sodium hydrogen carbonate or baking soda. So if we mix these two substances, the solution bubbles as carbon dioxide. So the evidence here, as you can see, are bubbles. So the bubbles formed are evidence of a chemical change. So whenever we see these signs, you can know and you can tell that you have a chemical change or a chemical reaction has taken place. So very quickly, as you can see, here we have a formation of a precipitate. It's the yellow substance. Here we have presence of gas or bubbles. Here we have release of heat and energy. Okay, so, and this is in your book. So if you just underline these, release of heat and as light, precipitate forms, bubbles over here, and then change in color. Change in color means that you have a chemical change. Okay, over here. Okay, over here, we're going to talk about electrolysis. Now, what do we mean by electrolysis? Electrolysis is a chemical process where water, liquid water, is decomposed to its main components, which are oxygen and hydrogen, through passing an electrical current through water. So in this tube over here, we have water as H2O, and we have here an electric current passing through it, and then we gather these two gases on both sides. So this is the name of the process. Please memorize that, electrolysis. If we want to compare comparison of physical and chemical properties. Now, we said that physical and chemical properties are different than chemical change and physical change, okay? So, again, if I'm talking about physical and chemical properties, I'm describing the substance or whatever system I have. Anything I use to describe using my senses is a physical property. So over here, they're giving you an example. Mercury oxide, physical properties are bright, red, odorless, crystalline solid, almost insoluble in water. All these descriptions are physical. The chemical properties is when I say that it decomposes when exposed to light or at 500 degrees Celsius to form mercury and oxygen gas. So its ability to react is its chemical property. Okay, same thing over here. If I'm going to talk about oxygen, I'm going to talk about the physical properties of oxygen, which are colorless, odorless, soluble in water. Its chemical properties is that it supports combustion, which is just another word for burning. Okay, burning. And it reacts with many metals. Oxygen reacts with many metals. Mercury also has physical properties. It's silver white. It's a liquid metal. In solid state, mercury is ductile and malleable and can be cut with a knife. Discussing its chemical properties, it forms alloys with most metals except iron. You can read all of this. This is all on page 10 in your book. Moving on. Energy and changes in matter. So whenever we have a physical or a chemical change, there's always energy involved, and it can be in various forms. The first one, heat. Okay, so if you mix two substances together, and you hold, let's say, the beaker, and you find it warm, that means energy has been released. Or light, as spark. Remember, if you go back to the previous slide, you can see the spark. Energy can be absorbed or released in a change. Guys, energy can be absorbed or released in any change, physical or chemical. So even physical. Okay, let me remind you. When you turn solid ice to liquid, the system absorbs energy, right? The system absorbs energy. So absorption of energy is involved. If steam is turned into water, then what you do here, condensation, and that involves release of energy. Release of energy. Now, of course, we always have to take into consideration the law of conservation of energy. Okay, that means that energy cannot be destroyed or created. Over here, we show you how we classify matter. So as you can see, and this is in your book on page 11, as you can see, matter is classified into pure substances and mixtures. You're going to ask yourself, can it be separated? If you can't separate that matter, then it's a pure substance. And here we're talking about elements and compounds. If we can separate it, it's either a heterogeneous mixture or a homogeneous mixture. Okay? And they give you examples over here. This is just a classification, again, on an atomic level. Okay? I'm going to get a clear shot of that. This is the definition of a mixture. It's a blend of two or more kinds of matter which maintain its identity and properties. Mixed together physically, can usually be separated. Homogeneous mixtures are called solutions. They are uniform in composition, like salt and water. Okay, so if I have a mixture or a solution of salt and water, and I take any portion from that cup, let's say, from wherever you take it, it's the same consistency. It's the same. Heterogeneous mixtures are not uniform throughout, like clay and water. If I mix dirt or soil with water, okay, it's not going to be homogeneous. We call that heterogeneous. Here you have examples of mixtures. First you have water and sugar, which is homogeneous. Okay. And then you have silicon dioxide and water. As you can see, it's not homogeneous. Okay. As you can see, first of all, the silicon settles down. Okay, it's not equally distributed, like in this case over here, the sugar and water. Of course, pure substances have fixed compositions. They're either compounds or elements. This is from the classification chart. It will differ in the mixture in following ways. Every sample of a given pure substance has exactly the same characteristic properties. And every sample of a given pure substance has exactly this, we said the same atoms, right? Remember? Now, when it comes to composition, the atoms that make up a compound is always fixed. It has a fixed composition. So water is always 11.2 hydrogen and 88.8 oxygen. This we don't need, by the way. This is not included. This is just another summary for it. You can just read it, giving you examples, as you can see, for homogeneous and heterogeneous. Thank you for watching, guys.